1e. Okay, very good. So that is a very important type of problem, extremely important. I think it's power 3 at the top and power 4 in the denominator. The reason I'm saying I think is because all these computers are so far away from me, so I can have room on the desk that I may not see it clearly. It's that far away. Okay, so I copied it correctly, correct? Yes? Can anyone
Yes.
confirm? As I said, they are 3 feet away from me. Okay, so in order to differentiate such a function, first of all, I have to remember to use the quotient rule and the chain rule. And watch me run out of room, like I always do. The top, 3x squared minus 1 squared times the inner function prime, 6x, multiplied by x squared plus 3 to the 4th power, minus. I'm going to write x squared plus 3 squared, which is 8th power, and I will write the rest in a different spot right here. Follow it. Still the same denominator, because I don't want to forget about the denominator. But now I copy the numerator, and I multiply by the denominator prime, which is 4, x squared plus 3 to the 3rd power, multiplied by the inner function prime. At this point, if I don't factor to simplify, I will never finish. Never is a long time. So I will not be able to finish in time to continue with another problem. So then I look at these two terms at the top, and I see they have 3x squared minus 1 in common. I see, after I rearrange, I will rearrange for the factors in front. I see x is in common in both. And I also see that this is common in both. So therefore, I will rewrite it nicely in one row now. Stop me if you have questions at any point in time. Okay, so first I will write that this is 18x, the first one, 3x squared minus 1 squared, and x squared plus 3, everything to the 4th. Now I have here 8x minus, of course, and then I have 3x squared minus 1 to the 3rd and x squared plus 3 to the 3rd. Now I realize that 2x is in common, and 3x squared minus 1 is in common, and x squared plus 3 is in common, and of course I have to talk about exponents. I have not talked about exponents at the top yet. Okay, this has power 2, this has power 3. I can choose only the smallest of the two. This has power 4, this has power 3. I can only choose the smallest of the two. At this point, I ask myself what is left. And this has to be a minus in between those two terms. 2 is out, x is out, so a 9 is left. This is completely out. From these 4, I took out 3, so one of them is left in. Now, 2x is out, so a 4 is left. These 3 are completely out, but from 3 I only took out 2, so I have a 3x squared minus 1. So the bottom line, what I wanted to say here is don't be afraid. These functions normally simplify quite nicely. Yes, only now I can do this. I remove 3 of those from the top, and I remove 3 of those from the denominator. Yes, I'll have to combine like terms here. If needed, I have to continue factoring, pulling something out. But for now, I will copy 2x. I will copy 3x squared minus 1 squared. And let's see what we have. We have a 9x squared plus a 27, and minus 12x squared and plus 4. over x squared plus 3 to the 5th power. Okay, don't sleep on me. I'm talking to this device on the left, on my left. Okay, so 9x squared minus 12x squared will be negative 3x squared. So I have to rewrite 2x, 3x squared minus 1 squared, and then negative 3x squared and plus 31. And over x squared plus 3 to the 5th power. And yes, now you know, you will know very soon, if you don't, why this needs to be fully simplified. And hopefully you understand why I don't like negative leading coefficients. Negative 2x, 3x squared minus 1 squared, 3x squared minus 31 over x squared plus 3 to the 5th power. Is that okay? Any questions? Any questions? Do we understand this problem every step? Anyone? Any questions on this?
Yeah, I think that's good.
Okay, now you said K, so I'm going to move on to E, F, I, J, K. Very good. So K has a natural log of x to e to the x, sorry, plus x e to the x. Okay, so y prime will be 1 over e to the x plus x e to the x. But now I have to multiply by the inner function prime. It's not going to be that wide, but anyway. So e to the x plus. The first function prime is 1 plus e to the x plus the second function times e to the x prime. So then the numerator becomes 2e to the x plus x e to the x over, and I see a common factor here, 1 plus x. I factor out e to the x from the top, and I get 2 plus x over e to the x, 1 plus x. Very nicely done. Those two go away, and what is left is just this. Of course, I recommend writing in the correct order, descending order, etc., etc. Fully simplified. Okay, you also said m. Let me look at m. Oh yes, of course m. It's x raised to the square root of x. There is no rule for this other than applying natural log to both sides and getting this. This is the intermediate step. And at this point, I'm able to differentiate implicitly, or I have to differentiate implicitly both sides. Okay, so I differentiate the left-hand side, I differentiate the right-hand side. I'm on page 3. Okay, natural log is prime is 1 over y dy over dx. This is a product. I differentiate the square root times natural log x, plus I leave the square root alone, and I differentiate the square natural log x, which is 1 over x. Okay, so all I have to do is multiply by this, and this is done. But I'll, instead of y, I will write x to the square root of x, and you don't have to do anything here. That's good enough. Okay. Anything?
Well, how did you?
A student was just asking me whether we are in. Of course we are in. Yes.
Just like how you knew to do ln or like natural log and implicit differentiation there.
Right. Because when we have a function raised to another function, no rule can be applied. We have no rule to differentiate a function raised to another function. We can still find dy over dx, but we have to apply natural log. There is no rule for this. You cannot bring down g, subtract 1 from g. There is absolutely no rule. For everything else, we have rules. But for a function raised to another function, we do not. Okay. Other questions for me? Is this okay?
Yeah.
Okay.
Can I go over numbers 4 and 5 on the old test too?
Which one? Say it again.
Numbers 4 and 5.
4
as
and
well.
5. 4 and 5 it is.